Hi, I'm Chris. I'm an iOS engineer on the media platform team at Instagram. My focus is on providing a delightful media experience by optimizing end-to-end visual quality. Today I'd like to share the story of how we adopted HDR. I'll talk about why we did this, some of the challenges we faced, our solutions, and the problem areas that are still ambiguous. So first off, why did we decide to do this? iPhone has supported HDR playback since as far back as 2017 with the iPhone X. So why do we suddenly care? The reason is the iPhone 12. In October of 2020, Apple announced the iPhone 12, which included a 10-bit Dolby Vision HDR camera, and it was enabled by default in the System Camera app. This previously rare format had become mainstream in the hands of the common consumer, and we committed ourselves to having the best-in-class implementation. If you watched the WWDC sessions from 2020, you may have inferred that a vanilla AV Foundation stack will get support for nearly free. Of course, our stack was far from vanilla. If you're an early adopter and received your iPhone 12 on launch day, you may have imported an HDR video into IG and seen something like this. We were in no way set up to handle the new format, so we did the next best thing: support via lack of support. Conveniently, we can opt out of dealing with HDR by explicitly asking the system for SDR color properties when we go to read frames out of the asset. This will invoke the system's tone mapper, and downstream code will be none the wiser about the content's original format. That's it. That's the talk. Thank you. Not really, though. We actually want to support HDR, so let's do this properly. From the client's perspective, there are three components of making a post that we need to address: editing, encoding, and playback. Editing is complex. If you're familiar with IG, you know we're not just talking about splicing plain video frames together. We have a whole suite of creative effects, filters, stickers, drawing, etc., that would need to be ported to both preview in HDR and be burned into an HDR video at encoding time. This is such a complex topic that we opted to skip it entirely by starting with a product that had no editing capabilities: IGTV. So let's talk about encoding. First order of business, we need to be encoding with HEVC using the main 10 profile. At this point, we were still using H.264, as previous investigation showed that HEVC could not achieve the levels of encoding efficiency that we needed at our target bit rates. I'm happy to report that iOS 14, launched alongside the iPhone 12, also brought great improvements to HEVC. It has therefore been our standard for iOS uploads since the end of 2020. So now we have HEVC. What about HDR? There's one more part of the picture to address. Every video upload going through Instagram goes through what we call a normal filter. This filter performs any scaling or transforming needed to ensure that the file being uploaded is correctly oriented and reasonably sized. Of course, everything at this point was only expecting 8 bits per channel SDR, and producing output that may have looked something like this. We can now operate on 10-bit pixel formats, though, and thus do this in HDR. The work behind this involves a whole lot of matrix math and shader code and could be a talk of its own, so I'm just going to say it's made possible by some of our talented engineers. And with that, we can upload IGTVs in HDR. In fact, we have been. Here's a fun fact. We've been fully preserving HDR for IGTV uploads, or what we now know as Reels with no creative effects, since mid-2021, and then relying on the server to tone map back to SDR while we work on HDR playback. On that note, let's talk about playback. As of last year, Apple offered two ways to play HDR video on iOS: the high-level AV player and the lower-level AV sample buffer display layer, or AV-SBDL. Of course, we had neither of them in our stack. In the spirit of least disruption, we opted not to replace all of our players with AV Player, and instead adopt AV-SBDL in a non-invasive location. This topic could also be a talk of its own. I'll summarize by saying that there were a number of performance implications that were different enough from our existing solution that it took some major effort to integrate. But AV-SBDL is in our codebase now, and it works. And it's quite magical the first time you see it in action within your own app. You too can experience this, as we put it into production earlier this year. There is a catch, though. In an app such as ours, where the entirety of the viewport is not always occupied by a single video player, some of the system's implementation details become apparent. In order to maximize the HDR effect, two things happen. One, the video player runs at brighter than normal levels, and two, any non-HDR content is dimmed. For a surface such as our Explore grid, in which we show many different posts that you may be interested in, this causes the HDR post to seem highlighted, and may cause unintended bias as to what gets tapped on. With a lack of a way to negate this behavior, we opted not to show HDR here. How though? Should we fetch an SDR copy for the grid, and then if you tap into it, fetch an HDR copy? This is not the scalable way, as it requires an additional download, and therefore a potential delay before it can get played. So here's another fun fact. You might be fetching HDR for your Explore grid all the time, but not know it, as we're tone mapping these back to SDR on the fly. We own our Playback stack, so we can do this kind of stuff. This way, we get the best of both worlds. Consistent brightness SDR in the grid, and already playable HDR when you tap in. Again, we could have a whole talk on tone mapping alone, and this year we do. Check out Boomy's talk if this is something you're interested in hearing more about. If you do tap into a surface such as our Reels player though, there's another hurdle. In Reels, we overlay a full-screen video player with a variety of controls for either interacting with or displaying information about the post. The creator's name, captions, comments, like and share buttons, etc. With an HDR video, these white overlays all become a dim gray, sometimes to the point where they're nearly invisible. We weren't sure what to do about this at first. Should we put a dark background behind the controls? Or maybe use different colors? Or perhaps not have a full-screen video player? Then, we learned of a new feature in iOS 16. It turns out that in 16, one can render UI colors in extended ranges, the same ranges that are used for HDR video. So perhaps instead of 1.0 for white, we now use 1.5 for white. What about our light gray though? And medium gray? Should I bug our design team and ask for extended versions of every color that we use? No, there's a more scalable approach. While a UI color can be represented as RGB, it can also be represented as HSB, hue, saturation, and brightness. So, what if we just increase the B part with some multiplier? I think this looks pretty good, and it's easy to tune in a globally consistent way. Now, we can make any overlay as bright as the underlying video. This works out very well legibility-wise, though we find that the ever-changing brightness as you scroll through your feed can be startling to some viewers. So what we would really enjoy would be a way for the player to respect the system's existing brightness level, rather than having to work around it. We have yet to solve this, but hopefully you'll open the app one day and find out when we do. Anyway, that's all I have to say about Playback for now. I still haven't talked about editing in HDR though. Up until recently, we were thinking we'd have to port our editor to AVS-BDL as well. Luckily, iOS 16 now offers EDR support in CA Meta Layer, so there exists a performant path forward for us to apply various creative effects. However, we have yet to define what it actually means to have such effects be HDR compatible. What does it mean for a color filter to be in HDR, for example? Can we still call it the Paris filter if the output looks different? Should there be an extended Paris? Or what if you had a GIF or music sticker, which is inherently SDR? Do we reverse tone map it to HDR? Do we now need to offer EDR colors in the picker? You'll just have to wait to see what we come up with. So that's the story so far. We've gone from 0 to non-zero amounts of HDR in our app, with a ways to go. And we look forward to helping to define the ideal HDR experience for all iOS apps. Thanks.